Hey, welcome back. This is now 2.2, and it's the multiplication property of equality. So what's happened now is we have another technique for solving equations. And basically the rule is that if you have an equation, say a equals some other number c, then you can multiply both sides by a non-zero constant, and it doesn't change anything. Okay, I mean, it changes the overall shape of the equation, but it's still an equation, and you can use this fact to solve your equation. So let's see how it works. Here's problem 1. We have x over 2 equals 8. And the end goal is always to get x equals something, right? So the problem with this equation is that pesky 2 underneath the variable x. So in order to get rid of the 2, we kind of, if it looks like it's being divided, we multiply, right? So instead of division of 2, we multiply 2. And if you do it on this left side, you also have to do it on the right side. Okay? Just for the sake of teaching, I'm going to put the 2 on that left side over 1, so you can see the direct multiplication. It's 2 times x in the numerator all over 1 times 2. So over here, I generally won't write all this out, but over here on the side, if you were to multiply straight across, it would be 2x, 2 times x, all over 2 times 1 is 2. And then you can remove these common factors of 2. 2 over 2 is the same as 1 over 1. So you get 1 times x all over 1, and of course it's just x. So on the left side, we've achieved what we wanted. We just have the x isolated. And then on the right side, we go ahead and multiply out, and we have our answer. Okay? So that's the multiplication principle in full effect. Let's see sort of the same thing, but division. Division is really just the multiplication by a fraction. So we kind of put it into the same category as the multiplication, right? So here I have 5x equals 25. Again, my end goal is x equals something. So what I'm going to do here is divide both sides by 25. And you could look at it as multiplying by 1/5. And a lot of times that helps later on if you could think of it more than one way. But the way people usually approach it is, and let me rewrite the original equation again. The way people usually do it in our class is just to divide both sides by 5, right? And then on the left, 5 over 5 is the same as 1 over 1. So you get 1x over 1, which is just x. And on the right, you could simplify that. 25 divided by 5 is 5. Okay? And then again, you can go over here to your homework and plug in the number. Okay, and that's pretty much the idea. Everything else is just going to be variations on this theme, and then eventually we need to put the addition property in with the multiplication property. Okay. So let's take a look at a couple more random kind of exercises just to make sure we cover all the bases, so to speak. So here I need to isolate the z. It's on the right side, but that's okay. That's still the same game. I'm going to divide both sides by 8. On the left, I'll have negative 20 over 8. That's the same thing as you could divide top and bottom by 4, right? So you'd have 20 over 8 is the same as 5 over 2. So you end up with negative 5 halves on the left. 8 over 8 is the same as 1 over 1. So you get 1z over 1, which is just z. And on my test, of course, you would write that as z equals negative 5 halves. Please try to write your work the same way I'm writing my work. I've seen people abuse the math notation and to the point where it's illegible, so you can't read it anymore. And we want to be able to read your work. And okay, let's see if we can find another one. Just kind of scrolling through here. Negative 24. Oh, sure, let's try this one. It's number 7. We got negative 24x equals 9. So again, I want to get x equals something. So what do I do in this case? I'm just going to divide by whatever's in front of x, the whole thing, including the negative. Negative 24 over negative 24 is just going to be, that's the same as 1 over 1. So you get 1x over 1. So we got our x. On the right side, 9 over 24 is the same as 3 all over 8. So I'm going to end up with negative 3 all over 8. Okay. Negative 3 over 8. Let's make sure that's right. Okay, oh, here's a weird one. Just because of that 0, some reason that zeros scare people. I don't know what it is. Anyways, here's 15m equals 0. It's the same game. You know, you want to divide both sides by whatever's in front of the variable. 15 over 15 is the same as 1 over 1, so you just get 1m over m, which is m. 0 divided by 15 is just a big 0, so m is 0 in that case. Oh, okay. So now here's where kind of thinking of division as multiplication by a fraction really pays off, because you'll have problems like you see on the left there, number 9. Let me write it out. 8 over 9x equals 16. So people that are conditioned to believe that division is always the answer will end up doing unusual things like this, which just looks terrible. You can pull it off, but it becomes more trouble than it's worth, right? Maybe some people would want to do this if they had no other idea. It's not a bad idea, but it turns out not to be the approach. You want to think of the multiplicative, the reciprocal of 8/9, right? So the reciprocal means the flipped version, basically. So here I have 8/9 x equals 16. To isolate x, I'm going to multiply by the reciprocal, the flipped version of the fraction in front of x. Okay? And of course, you do it on one side, you got to do it on the other. So I have these guys, 9 over 9 is the same as 1 over 1. 8 over 8 same as 1 over 1. So you get 1 times x, basically all over 1. That's just x. And then on the right, we can do some simplification. So 16 over 8 is the same as 2 over 1. Multiplying straight across, then you have 18 over 1, which is just 18. Okay? So it's similar to that problem above. I mean, normally what we would do is like divide both sides by 5, right? But the truth is, what you could also think is that you're multiplying by the reciprocal of 5 on both sides. So this idea that we're going to multiply by 9/8 isn't all that foreign. It's just kind of written in a different way, I guess. Anyways, 1/5 times 5 is give you the x, and then on the right side you get 3 over 5. But so division is really just multiplication. And okay, but let's keep on moving. I feel like I'm losing my train of thought. Let's try number 10. I think I did this in one of my classes. 12 equals negative 6/5 x, right? So with the negative in front, you may think, well, what do I do with the flipping? You know, it turns out what you do is just basically multiply by 5/6, but with a negative in front of it. So on both sides, you're going to multiply by negative 5/6. So we have times negative 6/5 x. And on the other side, you have to do the same thing. Okay. All right. So on the left, you could think of 12 as the same as 12 over 1. 6 goes into 12 2 times, and then you multiply straight across. So negative 5 times 2 is going to be negative 10 all over 1, so just negative 10. On the right, negative times negative is positive. Okay, whenever we get our answer, like if you look above there, that x equals 18, it's not negative x equals 18, right? That's not allowable. We don't want that. We just want x all by itself. So you have to multiply in here by a negative. It has to be negative times negative will be positive, and then the 5 will cancel with that 5, the 6 will cancel with this 6, and you just have one x at the end of the day. So x will be your negative 10. Let's make sure that's right. Okay, great. And here is one of the ones where we have that, you may think like, oh, I got none left to do, right? The answer is 60. But no, that's not true. You need r equals something, not just negative r. So how do I remedy that? Well, you're going to multiply both sides by negative 1. Okay. Okay, so on the left you have negative 1 times negative r. That's just going to give you 1r, which is r. And on the right you have negative 1 times 60, which will be negative 60. And if you kind of visually inspect what's happened here, and some students will think of it in this way, all you're doing is kind of moving the negative to the other side. So you kind of flip-flop the negative and you get your solution. So it should be negative 60. Let's check the answer, see if it's right. Yay. Okie dokie. Here's another one of those. So you're just multiplying both sides by a negative. It'll be 22. Sure, let's try this one. Well, no. So you just multiply both sides by negative 8. Okay, so this one's a little bit different, and we're simplifying before we do anything. So rule of thumb, simplify both sides first if you can. So here I have 5n minus 8n equals 12. 5n minus 8n is negative 3n. And then you're going to divide both sides by negative 3. Okay. So on the left there, you just end up with n. On the right, you have 12 divided by negative 3. Positive divided by a negative is negative. And then you have 4. Okay, so simplify both sides first. And this question, now we're getting into the combination of both the addition and the multiplication property. So we want to be able to put it all together. And usually what I end up doing is the addition property first and then end with the multiplication property. So in general, you do the addition first, addition and subtraction, and then secondly do your multiplication. For this type of problem, okay? Okay, so first I want to isolate the variable term. I want to get that 4x all by itself, right? So I'm going to move this 8 to the other side. And then on the right, I get 36. And then finally do the multiplication property. So in this case, I'm doing division, or you could think of it as multiplication by 1/4. On the left, 4 over 4 is the same as 1 over 1. So we get x. And then on the right, 36 divided by 4, that's just 9. Okay. Let's pop that in there and see if it's right. Yay. Okay. Let's find another. It's number 17. I have negative 4y plus 2 is negative 10. Okay, so first things first, I'm going to do the addition property. Here it's subtraction. So you get negative 4y equals negative 12. And then I want to isolate the variables. So the first step, they kind of say it's isolating the variable term. And then you want to just isolate the variable itself, okay, to get that y equals something. So here I'm going to divide both sides by negative 4. And then I'm going to end up with y equaling negative divided by negative is positive 3. Put it in there, yay. Okay, so that's good stuff. More of the same stuff. Sure, let's try this one. So number 20, we have negative x minus 6 equals 8. So I'm going to add 6 to both sides. Again, isolating the variable term. And so I'll have negative x equals 8, 9, 10, 11, 12, 9, 10, 11, 12, 13, 14. It looks like a little domino. Anyways, negative x equals 14. I'm going to multiply both sides by a negative 1. Or you could just flip-flop the sign if you like that way. And of course, you get negative 14 for your solution. Negative 14. Yay. This one looks like it's a bit jumbled, right? There's variables on both sides. So the deal will be to collect all the variable terms on one side, all the constant terms on the other. Let's take a look. Okay, so you collect, or maybe you can even think of it like an equation, like a shorthand. Variables on one side. Usually we like to put the variables on the left, and then the constants on the other. Okay, so I'm going to move the 7x over. If it's plus 7x right now, you got to minus it on both sides. So I'll have 2x. And on the right, I got negative 14 left. And then finally, isolate the variable, dividing both sides by 2. Get x is negative 7. See if that works. Negative 7? Yes, sweet. Okay, so more of that. Let's skip ahead a little bit. And sure, let's try this one. So this, we have a mix of variables and constants on both sides. Okay, so I'm going to move this variable term over. I don't like to do 100 things at once. For me, it's hard to multitask, right? So I just like to keep it simple. The more things I do, the more likely I'm going to make mistakes. And okay. So over here, what do we got? Negative 21x, and then minus 8. And then on the right side, I have a 6. So then I'm going to add 8 to both sides. I got negative 21x equals 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. And then I'm going to divide both sides by a negative 21. And I get x equals, on the right, it's going to be a negative, right? So positive divided by negative is negative. I can divide top and bottom by 7. So I get negative 2 all over 3, and I think that'll be it. So you got a nasty fraction there to deal with. What do we got? Another one of those. Sure, let's try this one. Problem 27. Negative 7y minus 6 equals 1 minus 6y. All right, this time I'm going to add 6y to both sides. And so I'm collecting all the variables on one side, right? So negative 7y plus 6y is negative 1y. I just write negative y. 6 equals 1. And then I'm going to add 6 to both sides. And I get negative y equals 7. And again, I can't leave it like this. All right, so I need to flip-flop the signs or multiply both sides by a negative 1. And notice that I put those parentheses in there, because if you don't put the parentheses in there, look what it looks like. So I have negative y equals 7. And then if you just put negative 1 on both sides, now it looks like negative 1 minus y equals 7 minus 1. So maybe it's like this, you know? And I'm reading your work, and I'm like, what's going on? This is bad news. So you want to use those parentheses to indicate multiplication, so you don't end up having these miscommunications. It's all about communication, really. It's hardly about math. But anyways, we have y then equals negative 7. Photomath, it's just learning how to present it and write it. So here's a weird one. I think they want you to solve for y. And they have these funny shapes. So some sort of geometry land. I don't know if it's a pentagon or something. All right, so you just pretend those shapes are numbers. And here I'm going to multiply both sides by triangle, right? So multiply by triangle. And so over here, supposedly the triangles cancel out, right? So these are common factors. That will give you a y. And then I don't really know how to combine the triangle and the pentagon, so I'm just going to leave it as it is. And then I go to my answers. The only one that even looks similar is D, right? It's triangle, pentagon. I have pentagon, triangle. But the truth is it works, right? It's the commutative law of multiplication. Because if you think about it, 3 times 4 is going to be the same as 4 times 3 in our math universe. So I think pentagon times triangle is the same as triangle times pentagon. Okay. So let's see. All right, so another one of those is going to be, hopefully you can figure that out. And then we start getting into story problems again, right? So let's try here number 31. Use the information to write an equation. Let x represent the number described in the exercise. Solve the equation, find the number. If a number is divided by -9, the result is 6, find the number. So I kind of translate everything directly in order. So a number, I write x, divided by -9. So I'm going to write divided by -9. The result is, so equals, and then 6. Okay. So the first they want you to type the equation in there. So I'm going to write x divided by -9 equals 6. And then check that. Yay. And then what the heck is the number, guy? So I'm going to go ahead and multiply both sides by -9. On the left, the -9s will divide out, and I'll have x. On the right, 6 times -9 is -54. So it sounds like it's -54. Whoops. -54. Yay! Let's see what else I got. This is just a number one of those. This is one of the weird ones. Be careful. 4 subtracted from the product. So you're not going to write 4 minus 5x or anything. You have to write 5x minus 4, right? Let me make that clear. It says 4 subtracted from the product of 5 and a number. So I mean, normally I've kind of been I kind of train people to write it like 4 minus the product of 5 and a number. But that phrase subtracted from reverses the order. Okay, so it'll be 5x minus 4. And then it says that is 51. Let's just make sure that's right. Sometimes I get these wrong. 5x minus 4 equals 51. Yes, I do make mistakes. I am human. And then you got to solve it. We'll leave it there. Yes, I know. All right. Another one of those. And, so this is the lightning. So when I was a kid, I think my mom told me when you hear lightning, or when you see the lightning, you can count like for every second it's a mile away, right? You count in between the lightning. You see the lightning and then you hear the thunder, right? So you count seconds in between the lightning and the thunder, and that kind of tells you how many miles you are from the lightning strike, right? So this is that, but it's more technical because it gives you a nice formula. All right, so if we get problem 34, they give you this formula, m equals n over 5. M is going to be the miles from the actual lightning strike. And then little n is going to be the seconds in between that gap, between the seeing the lightning and hearing the thunder. And I butchered the word lightning. Sorry about that, I put an E in there. Lightning and thunder. Okay. So I like to define my variables, write them out so I can reference that rather than having to search for them in this huge paragraph. And then I'm going to go back here and read it. So the formula m equals n over 5 miles, your distance m, in miles from the lightning strike. In a thunderstorm, if it takes n seconds to hear the thunder after seeing the lightning, use this formula to answer the following questions. If you're 9 miles away from the lightning flash, how long will it take for the sound of thunder to reach you? Okay, so miles from the lightning, in that case, that's the m variable. So you're going to put m equals 9. And then to get the number of seconds, you plug that into the formula, right? So 9 for m equals n over 5. And then I'm going to multiply both sides by 5. So I end up with 45 equals n. So it must be 45 seconds. Jeez. So my mom's model, it was like every second represents a mile, right? So the number, her formula would have been n basically just equals m. And in that case, if I was sitting in my house and I saw the lightning and I counted 5 seconds between the lightning flash and the thunder, it would be 5 miles away. But in actuality, if it was 5 seconds from our formula, the number of miles would have been 1. So it was a lot less safe than my mom. She had a tendency to lie. Oh, you'll be okay. You know, there's bombs coming in. Oh, wow. Oh, sorry, that's the wrong question. No wonder. That's a different question. Yeah, 45 seconds to reach you. That was good. What is this one? Oh, so here's a little harder one. They got some decimals, so you're going to have to get your calculator out and do some work. Okay, cool. So as usual, thank you for watching, and I hope this helps a little, and I'll see you next time.